Okay, exercise 10F question 4 part C. Right, the magnitude of the force exerted on the pulley by the string. Right, so if I think about it, this is the bit which is exerted by the pulley, by the string on the pulley. It's just this bit here. So I don't need to worry about anything else. It's just the tension of this string here and this identical tension pulling at 90 degrees to it. So what I'm basically going to do is just take a screenshot of this and then go into it in a bit more detail. Can I do that? Yes, there we go. Right. So I'm going to get rid of the rest of this diagram now, just so we've got, because we've understood that. That's, if you want to refer to that diagram, you can refer to the other question. So if I look at this tension here, I'm going to make this nice and big. If I think about it, if there's something pulling this way and this way identically, then the resultant force is going to act in this direction here. Yeah? Okay. Actually, it might even be easier if I can't do that. Right. So if I think about it, that resultant force is going to be coming out in this direction. This is the resultant force. That's bad. Let's just use a red line. And, right. Sorry, faffing about. So this would be the resultant of these two tensions, yeah? Okay, I'm just going to continue these lines down because it will help me in a second. That's a terrible line. And this line across here. Right. What I'm now going to do is just make a couple of right angle triangles. So here would be a right angle triangle and here would be an identical right angle triangle. Now, if I know if this tension here and this tension here, that's going to mean this is going to be acting completely in the middle. All of this is 90 degrees, therefore this angle would be 45 degrees. I then have an identical triangle here, 45 degrees. Okay, I'm just going to consider one of these triangles. So let me draw that in a different color, blue. So if I think about this triangle here, let's just take it over here. So we have this triangle. Let me label it nice and clearly. This is my tension. This is 45 degrees. And this is the force that I want, which is this bit here. I'll just call it X. Okay. Adjacent hypotenuse. If I think about it, I'm going to have cos 45 equals X adjacent over hypotenuse. Rearranged, if I can get to that bit there, we will have X equals T lots of cos 45 will be the force exerted by that bit, but then I have an identical triangle here. Therefore, it's going to be the magnitude of the force is going to be 2 lots of T cos 45. So whatever T is, which I worked out from the previous thing, therefore I'm going to have 2 lots of, good, I did right in this time, 27.6 times cos 45 is going to give me 2 times 27.6 times cos 45. Should be, to 3 significant figures, 39.0 newtons. Okay. Let me know. I know that's a little bit confusing. Have a think about that one and come back to me with any question. I think I found a good video on YouTube. In fact, I can tell you the Math Genie one on this is quite good. If it still doesn't make sense, then let me know and I'll send you out a link to that YouTube video. All right. Thanks a lot, guys. Bye.